morning, one and all. I hope you have enjoyed the last two sessions by our resource persons and you have learned many things. Today we are our resource person is Dr. G. Mahesh. He is currently associated with the KMIT Engineering College, working as associate professor in of mathematics. He obtained his PhD from Usmania University and masters from NIT Warangal. He is a meritorious student in MSc. His specialization including the singular pattern problems and root finding methods. His research interest focus on numerical and computational techniques for solving mathematical problems with a particular emphasis on efficient numerical methods and their application. Dr. Mahesh has published the 12 research papers in various focus indexed journals and has actively contributed to the academic and research activity in the field of computational and applied mathematics. He also participated and contributed the faculty development programs, workshops, and technical sessions related to the numerical methods and computational mathematics. He is keenly interested in promoting the applications of Python and modern computational tools in mathematics problem solving, teaching, and research. Sir, welcome, sir, Mahesh, sir. So now you can start your session. Our people will enjoy.
Thank you, sir. Thank you for the nice introduction. Is it audible?
Yeah, it's audible.
Yeah. Okay, sir. So I'm sharing my screen. So can you able to see my screen?
Sir.
Yeah. So I'll this is a Jupyter notebook. This I opened through Anaconda Navigator. So we can use we can run the Python program either using Anaconda or Jupyter notebook, or we can just install the Python. So in this Anaconda Navigator, we have many other features also. Like we have a Jupyter notebook.
Sorry, sir, you are sharing only.
Then Jupyter Lab. You can use any one of them. So this is the easiest way. And if you install the complete Anaconda Navigator, so that will be very easy for executing the programs. Okay. So today's session, I'll be more concentrating on the root finding methods, bisection method, Newton-Raphson method. Then in the afternoon session, I'll be discussing the programs on solving linear system of equations. So before going to the bisection method, so I want to discuss some basic functions which are used in the my program. So I think the previous speakers might have covered, but just I want to go for a small repetition for 5 minutes. So here, this is a Jupyter notebook. Here,
sir, it is not visible,
I'm
sir.
defining an equation. This is a string, actually. So
excuse me, sir.
Excuse me, sir.
Sir, your screen
you are
is not
sharing
visible,
the
sir.
Teams screen, sir. You are not sharing this Python screen. It's okay, sir. Now it's coming.
No, it's good. Thank you, sir. Yeah. So here, before going to the bisection method, I would like to discuss some basic functions which are used in the program. So here equation, here it's the string. So the equation for which I want to find a root, I'm defining an equation. First of all, a string. So because in the Python, everything you give it as a string, then we need to convert it to either integer or the equation or any float type of things. So first I'm defining it as a string, then I'm taking a is equal to 1. I'm using a replace function. So it will replace x with string a. Now I got the resultant as 1 double star 2 minus 4. This is not a numerical value, this is a string. Okay, next I'm using eval function, which is used to find the value of this one. This is nothing but 1 square minus 4, that is minus 3. Okay, so here another example I've taken. So parallelly you can practice in your laptop, so that if you get any error we can discuss. Okay. So I'm going for next example. Here equation is x cube minus 4x minus 9. So I'm taking a is equal to 2, replace x with string a. So equation dot replace x comma string of a. Then x is here, wherever x is there, that is replaced with 2. So 2 double star 3 minus 4 star 2 minus 9. This is 8 minus 8 minus 9. So minus 9. So in this way, we can evaluate value of value of an equation at a particular point. Okay. Now, suppose if I have something like transcendental equations, it will not work. Sine of x minus 4 will not work because this is a special math function. This is a basic function, polynomial function, it will work. But for a special type of functions like trigonometric, inverse trigonometric, square root, all those things, I have to include one more line saying that from math import star. Star represents that I'm importing all the available functions in the math package. Okay, so from math import star. Now it will work because it is converted to mathematical function. Now it will evaluate equation dot replace x star string a, where a is equal to 1. So this is the value of sine 1 minus 4. Okay. So is that clear? Now I'll go for the bisection method. So first of all, I think everyone knows the procedure, but just I want to go for a small quick recap of the bisection method. So we know that bisection method is a numerical technique used to find the real root of an equation of x equal to 0 when the function is continuous on an interval 0, a. So first we have to choose the two initial values a and b such that f of a into f of b is less than 0. Here f of x is treated as an equation, an expression, and we are evaluating the expression value at a and at b. Okay, that's why I'm using that evaluate function. So using that evaluate function, I can find f of a value, f of b value, and we are checking this condition f of a multiplied with f of b is less than 0. Okay, so there is a change in the function sign between a and b. So according to intermediate mean value theorem, a root exists between a and b. So what we'll be doing in the bisection method, we'll be taking a midpoint C and we'll calculate C. If f of C is equal to 0, then C is the exact root. So otherwise, we need to evaluate the root. So determine the new interval. So we'll check f of A multiplied with f of C is less than 0 or not. Assuming that f of A is positive and f of C is negative. So then the root lies between A and C. Otherwise, we need to set B is equal to C. Otherwise, f of C into f of B less than 0, the root lies between C and B, then set A is equal to C. So repeat the process, step 2 and step 4 until we get the required accuracy. So here I'm taking something like tolerance as epsilon. So when we reach this condition, we'll stop the process and we get the root. Okay, so that is the procedure we are using in our program. So here I've used different ways to evaluate the bisection method. So generally, how we'll be proceeding? I have some equation, and I'll go for some initial guess 2 and 3. Here my equation is x cube minus 4x minus 9. And here I've taken the a value 2 and b value 3, so that this function changes its sign between 2 and 3. Here I'm fixing the number of iterations also. So here what I'm doing, I'm fixing the number of iterations. Or we can do another way is we can fix the error. Accordingly, we can stop the procedure. So I'm using a for loop for I is equals to 1 in the range n. What this will take? I will take the values between 0 to n minus 1. In Python, the indexing starts from 0. So I initially takes 0. Next value it will generate 1, 2, 3, and so on like n minus 1. Here I have taken n is equal to 15. So it will run this loop for 15 times. That is from 0 to 14. So as per the procedure, I'm taking the midpoint. C is equals to a plus b by 2. And here I'm using this evaluate function. Here, what you've done in the evaluate function, first I'm going for basic polynomial function. So we are replacing x with string a value. A is 1. So we got 1 double star to minus 4 and we're using eval. So I'm using eval equation dot replace x star x comma string of a. So in this expression, it will replace x with 2 and it will evaluate the value. Means f of 2 value. And similarly, f of c value. Because we already know that the root lies between a and b. So if there is a change in the sign between a and c, then b should be replaced with c. This is with our procedure. This is the condition. F of a multiplied with f of c less than 0, then the root lies between a and c, set b equal to c. So same procedure we are using. B is equal to c. Else means if there is no sign change between them, so there is a sign change between c and b, then we'll be replacing a with c. And this is indentation. Indentation means the for loop will run up to here only. Because these lines are within the for loop. If I'm using the print statement within this for loop, then this is included in the for loop. But it is outside the for loop. So these are indentation. So after executing this loop for 15 times, that is from I is equal to 0 to 14. So we get the root. So the approximate root is this. Any doubts in this program?
Hello.
Any doubts in this program?
Sir, please repeat once again, sir.
Sorry, sir.
Repeat once again. Repeat the once again, sir, briefly again.
Okay. See, I think the procedure is clear. Means I think everyone knows the procedure, but so first of all, for a given equation, I'm taking the two initial values a and b such that f of a into f of b is less than 0. So then the root lies between a and b. First, we are finding the midpoint c is equal to a plus b by 2. Bisection is dividing that into two intervals. Then at each interval, we are checking the condition. Now, if the f of c value is equal to 0, then exact root. So generally, we won't be getting a single step, but that's the condition we need to check. Otherwise, proceed to the next step. So we are coming to the next step. The new interval we are designing. So f of a into f of c less than 0 means there is a sign change between a and c. So b is replaced with c. Otherwise, f of c into f of b is less than 0. Then the root lies between c and b. Then in that case, we have to set a is equal to c. So repeat the steps 2 and 4 until we get a desired result. Means you have taken the absolute value is less than epsilon, then we get the desired root. So that I am implementing in this program. So here I'm using this equation x cube minus 4x minus 9. First I'm defining it as a string. Okay. Then I'm taking the initial values 2 and 3. So here generally I don't know the initial value. I need to do it manually. So I have automated this procedure also in the coming programs. Okay. So, but initially we are assuming that when initial values are given, this program is when initial values are given. If the initial values are not given, so I have taken automatically, it should take the initial values also. Okay. So now a is equal to 2, b is equal to 3, and n is equal to 15. So for I is equals to I in the range n, and range of n generates the numbers from 0 to n minus 1. So now here I will take the value from 0 to 14. So whatever is the case, this loop will run for 15 times. Okay. So I'm not just take the condition now. I'm just giving the number of iterations. Okay. So c is equal to a plus b by 2.
Excuse me, sir. Sir, what is n, sir? What is n?
N is nothing but number of iterations.
Number of it.
Yeah.
Okay, sir.
So I fixed the iterations. Later
How
on
to
the
take
program,
15?
next programs. Yes, ma'am.
We have to take 10 also, no?
We can take 10 also, no problem. It will, the accuracy might be not exact. You may be coming near to, suppose if you see this value 2.706, if I take n is equal to 10, then I got not much closer.
Accuracy value is.
Huh?
Okay, sir. Understood.
Yeah. Just I'm using a more number of iterations so that ensure that we get a more accurate route. That's all. Okay. So here I'm evaluating the function value, the equation value at A and at C. Because we already know that the root lies between A and C. So I don't know whether the root is between A and C or B and C. So first condition what I'm using, f of A into f of C less than 0, then the root has between A and C, and B is equal to C. So that I'm using. Other else case is what? When this is greater than 0. Means f of B and f of C, there is a change in the sign. There is a change in sign with the f of C and f of B. Then we have to set A is equal to C. So else case A is equal to C. So this for loop is repeated for 15 times. Then the C value, whatever we get, is displayed. Okay.
Excuse me, sir.
You want to execute?
Sir. Hello.
Yeah.
Sir, str function stands for
Which one?
str.
String.
str means string.
String. Okay, sir.
See here in this example, X is replaced with A and A value is 1. So I'll get 1 double star 2 minus 4. But it is not a mathematical value, it is a string. Okay, now I'm using eval. Eval is a function which converts the string to a numerical value. This is nothing but 1 square minus 4. So 1 minus 4 minus 3. Fine, sir?
Okay, sir. Okay.
So this is where we got the root. You want to execute it? Sir, should I give some time to execute them?
Excuse
Yes, sir.
me, sir. Excuse me, sir.
Sir, tell me.
Sir, is there any way where we can plot this graph, sir, on the graph? Can you show it? How do you visualize this bisection method, sir? Graphical visualize. Can you show that, sir?
Madam, for that I have to include some more functions here. Actually, I have not
Yes,
come
sir.
with a visualization part. I'm just going for the finding the root
Oh,
methods.
okay. Okay, sir, at least for any of the one methods, can you just maybe in the afternoon session, one visualization program that will help us, sir?
Okay, ma'am. Okay. I'll try for that.
Okay, sir. Yes, sir. Thank you, sir.
So should I use the time for execution or should I go for next program?
Sir, we will see the execution part as well, sir.
Sir, I just typed everything in the Jupyter, sir. It's showing some error.
Sir, it is showing some error.
Can you share the screen so that
Sure, sir. I will post in chat, sir.
anybody want to share the screen?
Sir, can you see the screen, sir?
That's expected. So see this else is not in the for loop. Indentation, I told you, no? Indentation. Else should be below this B. Give a tab.
Sir, can I
Before E.
interrupt you? 1 minute, sir. No?
Yeah.
Sir, this error is you can put the colon at the end of after the 0, sir. That is the
No,
syntax for
that might be the error, but this is not in this, first of all, the syntax form. So that may give error in the if condition also. See here, just see my program. If you want it,
Yes.
just take a peek of my program once, then you can check.
Sir,
See you.
use tab for else. In the
Yeah,
at the line of else, if she
and
at the
also
line of
here
else,
if
use tab
within
for
the if
else,
equation b equal to c.
else, so
You
that
have
it will
written
be
like this.
corrected.
You have written like this. Because of that, it is giving error. And the print statement is not in the for loop. If it is in the for loop, the print statement will be executed 15 times.
Sir, I'm unable to understand.
See here. I'm just sharing my screen. Look at you. See here. See what you written is like this. Something like this you written. So the if condition is not entering within this. It says indentation means within the for loop, if within the if condition, it should be there. Then only it will execute. If then it's going back to directly print. Okay. Just do these changes and check the number of brackets. Here to here one bracket, then here to here one bracket. You just check the closing. We have done whether correct closing or not. So 1, 2, 3. 3 openings and 3 closing for f of a, and 3 opening and 3 closing for f of c. Okay.
Okay, sir.
Here. Here in this second program, what I've taken, the same function I've taken, x cube minus 4x minus 9. Here, when the initial conditions are not given, so the program will generate the initial condition that it will evaluate. Otherwise, the procedure is same. So I've taken assuming that the positive root. So a is equal to 0 and b is equal to a plus 1. What I'm doing, while the evaluate equation replace x with string a multiplied with equation replace string with b, this is greater than 0, then a is equal to b and b is equal to a plus 1. So while this condition is satisfied, I'm repeating this program, this loop, while loop. Okay, so here first what it will do is it will check for 0 and 1. If it is satisfied, then it will come out of the while loop. No, then it will take 1 and 2. Then it will take 2 and 3. Then it will take 3 and 4, like that. So it will go on repeating until this condition is satisfied. And once the condition is satisfied, it will come out of the while loop, saying that the print statement saying that the root lies between a and b. Okay. Now same, I'm using this, otherwise the program is same. You can just add these values, these equations. Can you execute and check whether it is working or not? Is it fine? Can I move to the next one? Here, it will automatically evaluate the initial conditions, the root lies between n 2 and 3, and approximate root. Okay. So this is generally for polynomial functions. We doesn't require any other package to be included. But if it is something like any trigonometric or exponential function, then we have to use the math function. The same program I have written using the error. So the error between the last two iterations are less than the given tolerance. Here I've taken 10 to the power of minus 6. The meaning is 1 e power minus 6 plus 10 to the power of minus 6. So if the two consecutive roots, if the error is less than 10 power minus 6, then it will stop the process. Okay. So here I'm using a definition. I'm defining a function. So this is a define DEF is a function which defines a function. To define f of x is return x cube minus 4x minus 9. That was a simple program. It was something like little complicated part. Not much complicated, but what we are doing is we are defining a function and we are calling that function every time. Okay. So define f of x is this. And another function I'm defining is a bijection. This is a whereby procedure of the bisection method lies. So in this function, what are the inputs I have to give? A, B, then what is the error you want, and what is the maximum number of iterations? Maximum number of iterations. It will not run for all the iterations. Whenever condition is when the error is greater than this, then it will stop the process. Okay. So first condition f of a multiplied with f of b greater than or equal to 0, then the bisection method fails. The root f of a and f of b must have opposite sign. Okay. Next, here I have to give the initial values. In this program, I have to give the initial values. Suppose in the previous program, if I give input as 1, 2, it will print the statement. It will print the statement. Then otherwise, what it will do if they are of opposite sign? Actually, here it is failing because they have same sign. That's why the root doesn't lie between A and B. Suppose if I'm going for they have opposite sign. So if I in the range maximum error, maximum iterations. So it is taking the value from 1 to 0 to 99. And C is equals to A plus B by 2. Here, this is a print statement. I'm using it to display the output. Not a graphical display, it's a tabular display. Okay. Now, here I'm checking that condition. Absolute value of f of C is less than the tolerance limit, or the absolute value of b minus a is less than tolerance. Then print round root found and rounding it to 6 digits, C, 6 digits. Then return the C value. So here is a procedure. F of A multiplied with f of C is less than 0, then B is replaced with C, else A is replaced with C. So here I'm using the function. In the function, I am to give the values, input vector value. A is equals to enter left limit, left endpoint A, B is right endpoint B. In this, root is nothing but A comma B. Bisection of A comma B means in this definition, in this procedure, I have to give A value and B value because these are fixed. The tolerance and max iterations are fixed, no need of giving it. Otherwise, we can make it as a variable, then we can give that input also. That's another way. But I have fixed the error and the number of iterations. So here, this is only the 3 lines program. Here I'm calling the bisection function. I'm calling here and giving input as A comma B. Suppose if we give here, we know that the root lies between 2 and 3. The root lies between 2 and 3. So I'm giving the condition the initial as 0 and 3. So I got the root at 23rd iteration. Same program, if I give the initial values as 1 and 3, the number of iterations might be less. Okay. So just I'll execute this program once. So it is asking the values. Say 0 and 3. So this is output I got it. So in 23rd iterations, I got the root. So we can just plot this. Once we have A, B, C, and F of C values, we can plot it. Suppose if I take
Excuse
the
me, sir.
initial values as some 2, 3. So I'll execute the same program with 2, 3. Then we may see that the number of iterations might be less.
Excuse me, sir.
So we got it.
Sir, actually, in our
21st iteration.
So sorry to disturb you, sir. So actually, in our syllabus, we are actually supposed to show it
So
graphically
your
to the
voice is very low,
students.
sir. Hello?
So now am I audible?
Yeah.
So now, yeah. So actually, in our syllabus, as per JNTU, we are supposed to show it graphically to the students so that actually they can actually visualize it. So as you were just mentioning just now, that actually given the values of A and B, we can actually show the root converging to a point after 21 steps. So
Yeah.
actually, could you actually show the particular code for that? Means how actually we
Okay.
can
In the afternoon session, I will
input the
share it.
value of A and B?
Yeah, because it
Yeah.
now I cannot test it here. So in the afternoon session,
Okay.
I will try to show the visualization of this program.
Definitely, sir. Done, sir. Done, sir. Thank you, sir.
Excuse me, sir.
You understand?
Sir, can you hear me? Sir, can you just explain that line, sir? C is equal to A plus B by 2 you have written. Below that, there is a print statement, print
Yeah.
F I plus 1. Can you just explain that statement once, sir?
Okay, madam. Okay. See here, first I value is 0. As I told you, the indexing starts from 0 in the Python, 0 to maximum iteration minus 1. In the previous program, n is equal to 15, it was up to 14. Okay. So here it is a printing format. This is for heading I've written actually. This is for heading. Okay, here what is it take is this is for the heading iteration. This statement is the first iteration A, B, C, and F of C. And there is a /t. /t represents that there is a spacing tab. The tab space is between iteration and A. Just a minute, ma'am. Yeah. This is iteration and the tab space between iteration and A. Again, a tab iteration
Yes, sir.
tab, two tabs between A and B. Here. This is for heading, ma'am. Okay. So
Yes,
that
sir.
the table looks nicely, so I've taken 2 tabs. Like it. This is for heading. The first print statement is for heading. And here, this print statement means every iteration I want to print. So I kept it in the for loop. So every iteration I want to display what is the A value, what is the B value, what is the C value, and a C value. Okay. So here I've included this in the for loop. First is I plus 1. So I plus 1 is I start from 0. So I'll started with my iteration with 1. Then A value. And then I'll explain what is 0.6f, all these things. A value, then B value, then C value, and F of C value. For iteration number 1. Then here point F, 0.6f means F means floating value after the decimal 6 digits. After this decimal 6 digits. Here after 2 we have a 6 zeros. Suppose if I want to make this as a something like 10, I can do it. So make it as a, so that I'll get a 10 digits after the decimal point. I'll take 2 and 3. Here we have a 10 digits. Here we have only 6 digits. I've changed only for A. Okay. So this is for rounding off. Up to 6 digits, I'm rounding it off. This statement will execute it for each value of I. For each iteration, it will execute and it will display the value. Okay. So any other doubts, sir?
Sir, excuse me, sir.
Yes, ma'am.
This return statement which you are using now, in many places you have used that return statement. So does that return statement, is it used for as a part of a function, or can be used anywhere?
See, ma'am, here, first here, if I talk about this return statement here, if the condition fails, it should not execute. So it will return none. The condition fails. This should just print that must have opposite signs. Bisection method fails. Suppose if I give here 3 and 4. 3 and 4. So 3 it is a positive and 4 it is positive. I'm assuming that 3 is positive, at 3 the function is positive and at 4 also function is positive. It will display this one. Or if I give 1 and 2, because sign is changing between 2 and 3. So 0 and 1, there is the same sign, 1 and 2, there is the same sign. So it will say that bisection method cannot be used within this interval, 1 and 2 or 0 and 1. Okay, so that is why it is written in none. Now, if I'm going for this, if the condition is satisfied, actually the iteration, the for loop runs for 100 times, 99 times, 0 to 99 times. But if I got the root between, then I have to come back. I have to come out of the loop, come out of the for loop. So that's why I'm taking here the error at C, the function value at C is less than the tolerance, the error, whatever we defined error here, this one, 10 to minus 6. So it will return. So that's why this return statement, because I have to stop my program in the middle. I did not wait. It will run for up to 99 iterations because my error is reached, my tolerance is reached. So I have to come back, come out of the loop. So that is a return statement. And here this return
Hello, sir.
statement. Yes, ma'am.
Hello, sir.
Yes, ma'am.
Sir, can you please explain about TOL 1E minus 6? I'm not followed thoroughly.
But here I'm taking the error as 0.000001. This is the error I'm taking.
Okay.
So that is symbolically I'm writing it as like this.
Okay.
We can use
Whatever
that one
the
also.
error we are taking, that one.
Yeah, that's the error we are taking. Suppose if we want more accurate, I want up to 10 digit accuracy. Then I will take minus 10.
Minus 10. Sir, one more thing is, can we make that statement here you are giving x cube minus 4x minus 9. One equation you are giving, right?
Yes, ma'am.
We are taking the values for input A and input B, right?
Yes, ma'am.
Interval values. So
Yes, ma'am.
instead, is it possible to take the equation, because in bisection method we are having number of problems. After solving, the students can check themselves that whether their solution is right or wrong. Can we give the input of equation also?
Yes, ma'am, we can give.
Yeah, can
I
you
will show
please
it. I will
give
show it
that
in
code
the.
for
I
Yeah.
will show it in the
Uh,
Newton-Raphson method programs.
enter that equation, enter equation.
Yeah, I
Can
will
you
show it in
please,
the Newton-Raphson method because I have included that feature in that Newton-Raphson method. Same way, we
Okay
can
then.
use that here also.
Even this we can implement
Yeah.
here also, right?
Yeah,
Okay, sir, then. Thank you so much, sir.
no. CM, your answer is here. I think equation, input, enter the function. This is the user input. The user is giving his own function, own equation. Okay. So here, I want to apply this method for something like sin x or exponential function or something like that. But the polynomial function that for that I have to include the math package. So from math, import star. So I cannot give directly the sin x like what we did here. The starting here.
Import star means what it will import, sir?
All the functions in the math function, math package. It has
For
all
example?
the mathematical operations like square root, cube root, or
Okay.
it will have trigonometric, inverse trigonometric, exponential, power functions, everything is included in the math. So
Okay, all the
instead of
mathematical
looking for one
functions, right?
particular, we'll generally give import star. Means everything is included here.
Okay.
Star means everything. If I want a specific, I can give.
Okay.
Like that. So if it is specific means again only sign, only exponential, like that it will be. Then it will be a mess. So better we give star. It will take all the mathematical functions. Okay. So here
Yes, sir.
input enter the function in x 0 and a plus 1. Like conditions also, it will take automatically. Then this is the while loop where we are checking where the root lies between A and B. Then input the number of iterations. Here I'm giving a facility that we can give the input number of iterations. If you want only run for 3 times, you can give n is equal to 3. So I'm not worrying about the error. I want only limited number of iterations. I can do. Okay. Here I'm not including the error. Here I'm giving a input values number of iterations. Do not check the error now. Okay. So here. Suppose here I'm executing this program. It will ask for the function now. It will ask for the function. So I'm giving sine of x minus x. That is saying that the root lies between 0 to 1. Number of iterations, I want to go for say 14 iterations. So this is the root. Or if you want to give any other function, I don't have any function right now. Here I have some function like sin x, sine of x minus 4 star x. We should not give 4x, it should be 4 star x. 1. Number of iterations, I want to give only 6 iterations. See, this is the root I want. So we can use this program for any function. Okay. So the same program we executed here, and I got the root at 0.33136. Here I've given only 6 iterations. So my root will be somewhere here only. Not so accurate. because less number of iterations are taken, 0.328, 6 iterations. Here I got 0.3316, 15 iterations. So it's more accurate. The error is this. This is error. Almost 0.0000110. This is the error. Just look at the program. Just give a minute. I'm just charge my laptop.
Sir, will you please share this PPT, sir?
Okay, ma'am. I'll share it to Srinivas, sir.
Yeah. Okay, thank you, sir.
Just a minute. So, oh, sorry. So this is also similar function where taken for the trigonometric function and input values, then checking the same condition and almost the same, but only for there are different for there we written program for polynomial function, here for trigonometric function. So next I'll move to the Newton-Raphson method.
Sir, excuse me.
So
Excuse me, sir. Trigonometric functions may be taken in either degree mode or radians mode, sir.
So sorry, sir, I did not get that. So can you repeat? No.
Trigonometric functions problem there now. Is a trigonometric function of sin x problem,
Yes, sir.
which can be taken in a degree mode or radians mode, sir. The program is same for both degree or radians mode.
It's only degree mode, sir.
Okay,
Degree mode.
thank you.
Because when you're going to bisection method, so in the calculators we're using only degree mode. Here it is also degree mode, not in the radians.
Okay, sir. Thank you, sir.
So this is a Newton-Raphson method procedure. I think everyone knows, but just want to have a glance on this method. So it's an iterative numerical technique to find an approximate real root of the function equation. It uses the tangent to the curve to obtain the successive approximations. So the main difference between the bisection method and Newton-Raphson method. So here we are using a tangent method, there we are using a midpoint method. And we require two initial conditions for the bisection method, whereas we require only one initial condition for the Newton-Raphson method. So the Newton-Raphson method mainly depends on the initial value. So if you take an accurate or near to the root, it will take very less number of iterations. And convergence point of view, this is a convergence by convergence. It is a 2, convergence value is 2. Whereas in the bisection method, the convergence is 1. So it is much faster than the bisection method. So here, use the initial condition x naught, evaluate f of x and f dash of x naught, then compute, check the accuracy. If the accuracy is not achieved, then set xn is equal to xn plus 1 and repeat. So this is a basic algorithm of Newton-Raphson method. So first we need to check for the initial value. The initial value will be more closer to the root. Of course, we don't know the root, but if you take more closer to the root, it will converge very fast. So here, same example I've taken there. X cube minus 4x minus 9, x is equal to 2. Initial guess I've taken is a 2, and number of iterations 15. So for I in the range n, f is equals to evaluate equation. Then df means derivative. So here it is not taking derivative manually. Here I have given the derivative 3x square minus 4. So in the coming programs where I have given the derivative directly, it will automatically take the derivative. We have one function called diff. That is a differentiate. So that is a function in the Python in the NumPy. So where it will take the derivative of the function automatically. So x is equal to x minus f by df. Then we get the root. This is a simple program where the initial condition is given, number of iterations is given, not checking the error. Without any error means not comparing with the error directly, going for number of iterations. Okay. So here the initial condition is given. Here I'm using the same condition which I used in the bisection method to check the initial case. So I've taken from a is equal to 0 and b is equal to a plus 1. Suppose here I know that the root is between 2 and 3. Suppose I don't know. It can be a negative root also. Then I have to change this value. So I can take minus 10. So it will check from minus 10 between minus 10 and minus 9, minus 9 and minus 8. Like that it will start. So here I've generally taken for a classroom session, so I've taken it only from 0 to onwards. It can be negative also. So in that case, I have to take some a is equal to some negative value, minus 10 or minus 20, so that it will execute the program and it will identify where is the root. So I have to come with some initial guess. I've taken x is equal to a plus b by 2. Or I can take generally x is equal to a also I can take, or x is equal to b also I can take. But it will take more number of iterations. Okay. So that's the reason I've taken initial guess as a plus b by 2, because we are sure that the root lies between a and b. Okay, so that's why I take initial guess as a plus b by 2. So say n is equal to 15 for I in the range n, f is equal to evaluate equation, then we get the approximate. Want to execute this program? Even this part you can just copy paste from the bisection method. You can just go for this 4 or 5 lines typing. That will be easy. Able to execute?
Sir, excuse me. Hello. Sir, excuse me.
Sir, yeah, tell me, sir.
Hello.
Yeah, tell me, sir. I'm able to hear you.
Hello, sir. Sir.
Yeah.
Sir, is there any ending for while loop as well as for loop? Where it ends while loop, where it ends for loop?
For loop, it will run for 15 times, sir. N is equal to 15. So 15 iterations have taken you. So while
Hello?
loop, so able to hear you? Able to hear me, sir?
Sir.
I can able to hear you.
Yes, sir. Yes, sir.
So here I have taken N is equal to 15. So fixed number of iterations I have taken. I'm not checking the condition. So we can do either things fix, either the number of iterations we can fix or we can fix the error. So once the error is reached, then we can come out of the loop. There we are using that return statement. We're checking the condition if the condition is satisfied, that is error is attained, whatever the desired error is attained, then we can come out of the loop. Okay, sir? So here, user input function. So here, define function, evaluate function. First, we are giving the input. So we don't know what type of input we can expect. So I included from math import star. So it can be any function you can give. Need not be a polynomial function. It can be any function. So initially, I'm inputting some function. Then this is we are defining the function, evaluate the equation. So whatever the function you are giving, that we are making it as evaluate. So that if you substitute the value, it will give a numerical value. Substitute any number, we can get a numerical value. And this is for finding the interval automatically. So I'm not giving any initial conditions. It will automatically take the initial conditions. As I told you, so my initial guess will be x is equal to a plus b by 2. Here I'm checking the condition that the sign of the function at a and b are different, opposite. So I'm using instead of using a derivative, manually I'll give the derivative there. Like if a function is given, here I've written the derivative directly, like x cube minus 4x minus 9. Here the derivative is given directly. But here in this program, I use the definition of the derivative. If you remember the definition of the derivative, what is that? F of x minus f of x plus h minus f of x by h. This is a derivative value. The definition of the derivative, where h is very, very small. So I have taken h is some small value, 0.00001. This is not error. This is the small value of h. Because if you look at the derivative definition, this is f dash of x is f of limit h tends to 0, f of x plus h minus f of x by h. Okay. So the definition I'm using here to find the derivative value. Is it fine?
Excuse me, sir.
Yes, ma'am.
You said there is some inbuilt function you just mentioned, sir. It's some diff.
Yeah. I'll come into
Something
that.
you told. So can't we use that now?
Yeah,
We are used
I'm
it
coming
here.
in the next program. I'm taking
Okay,
the next
okay. Later
program.
you produce. Okay. Next, yes, sir.
Actually, well, why I've written so many programs means for the classroom purpose. Suppose we have a lab for 2 hours or 3 hours. Right. So one program will not be enough for us. So if we give a program in 1 or 2 programs, they will complete within half an hour. So I've added some features in each of the program so that I can give multiple programs on each topic, each method. So that's why I
Sir,
take it.
please
Okay,
share
sir.
this programs,
Yes.
sir.
Ma'am?
Sir, please share these programs
Yeah,
all
yeah.
to
I
us.
will share it to Srinivas sir. I have his contact number, so I can share it
Yeah.
with Srinivas sir.
Yeah, if you share to him, he will share us.
I'm not in
Okay,
the
thank you, sir.
group, so I will share it to Srinivas sir. Okay. Anybody want to execute this program? What you can do is,
Yes,
my
sir.
suggestion, you want to execute it, take a pic of this and in ChatGPT, you can convert this into text. Then you can copy paste in your notebook, then you can execute it easily. It will not take much time. So next, I'm using some standard functions. This is in the SymPy. See, SymPy, we have I'm using here 2 functions, simplify and lambdify. So these are the 2 functions which are used to convert an equation, a string, to a mathematical form. Okay. First, I think the previous speakers might have shared some standard functions. Just I want to share something. So this is the PPT I prepared it for all the basic topics. Just I want to share some of them. So we have 3 things which are very, very useful for mathematics. One, Python. So we require 3 things. What is called NumPy. This is a NumPy. So this is a numerical Python. So it uses the numerical and scientific computing functions. So this is widely used in data science, machine learning, and scientific computing and engineering applications. So these are the NumPy is a package. In this, we have these modules. These are the basic 5 modules. Actually, it has a lot of modules. Whole Python might have more than 1,000 modules. So whatever the required for us, I'm just discussing those. So we have a LINALG. This is called a linear algebra. So this is a package, this module present in the NumPy package. So numerical NumPy dot linear algebra. So this is used for linear algebra operations like matrix multiplication, determinant, eigenvalues. I think the previous speaker might have discussed all these things, but here I want to discuss more thing on NumPy dot linear algebra. Here, these are the some standard functions like solve a comma b. This will solve the linear equations that we'll discuss in the afternoon session. So determinant, inverse, and all those things. Matrix underscore rank, transpose, singular value decomposition. So we have fast Fourier transform, random number generations, polynomial curve fitting, polynomial fitting, all this. We have all inbuilt functions. So we can use them to get it done very easy. So this is a cheat sheet. So it will give all summary that is for useful for especially for computational mathematics. Then we have a SkyPy. This is a scientific Python. Scientific, that is a numerical and scientific computing. This is a scientific computing. This is a more advanced than NumPy. It will execute much faster than the NumPy functions. So it is used generally for advanced mathematical functions. So it also includes linear algebra, numerical integration, optimization, statistics, signal processing, differential equations, and all those things. So in that linear algebra, so I have a solve. Some features, some functions are more advanced in this SkyPy compared to NumPy. So we have a LUA. This is nothing but linear LU decomposition, which we use for what I say solving the system of equations using LU decomposition. You have QR decomposition, SPD, and all these things. Then we have a SymPy. SymPy is nothing but a symbolic Python. Symbolic Python. So symbolic Python is useful when we are defining dependent variables and independent variables. So as a dependent variable is treated as a function and independent variable is treated as a symbol. Okay, so we use this SymPy for converting or converting a symbolic symbols to a mathematical function. So these are the some basic things we have. So in the SymPy we have a lot of functions. So in that I'll be using this function called simplify. This is a simplify the expression. This will simplify the expression, means a symbol is converted to a mathematical expression. Here. This is symbols. Symbols is for independent variables x, and simplify is a function from SymPy used to convert a string or a Python expression into a symbolic SymPy expression. Then we have a lambdify. Lambdify is again a function from the Python library SymPy used to convert symbolic mathematical expression into a normal Python function. Normal Python function that can be evaluated numerically. Okay. So here I'm using the SymPy because it is a function called DIFM. This is for differentiation. So equation sine of x minus 4, it is not a mathematical function now. It is just a symbol. So now I'm applying simplify. It will convert this to a expression. Then I'm using lambdify so that I can use it as mathematical. Here I want to find sine 1 value, sine 1 minus 4. So I could not get it here. First I'm simplifying it, then lambdifying it, then I got f1, then f1 of 1 value I can get it. Okay, directly I cannot get sine 1 minus 4. Okay, so if I'm using the SymPy package, then I have to use these functions. I can use star also, but I want to just show you that I used only these 4 functions, so I named them symbols, differentiation, simplify, and lambdify. In my Newton-Raphson method, I used the differentiation. See. So to find the root of an equation using Newton-Raphson method, user input with function and derivative function. So here the derivative will be calculated automatically. For that purpose, I'm using the SymPy. And mathematical function, so I imported from math import star. X is the symbol. Take the input function, input this. Whenever I get an input, that is always a symbol. In the Python, we cannot get a mathematical function as directly. Whatever you get, input, that is a string. That we need to convert it back to expression that mathematically numerically calculation. So that's why I have to use simplify and lambdify. These two functions are used. So f expression is simplify equation underscore input. So whatever input you are given, that first time simplify, then differentiating with respect to x here, diff f expression. I cannot differentiate directly to this equation because that is not any function. That is just a symbol, or that is just a string. So for that, I'm to simplify first, then differentiating. So diff differentiate expression. So then I'm lambdifying it. Lambdify only to convert it to a numerical function. So now my expression is ready. Now my mathematical function is ready. F is a equation and df is its derivative. So here I've taken some float. Here, see, actually, if I don't give this float, it will just take it as a string. If I give 2, they take it as 2 as a string, not a number. And convert this to either an integer or a float. Then only it becomes a number. So float input, enter string, enter starting value of the initial guess. So when I taken b is equal to a plus 1, then we checking that condition. Then the root lies between a and b. Now take midpoint as the initial guess. You can take anything, like I've taken an arithmetic mean, you can take geometric mean, you can take harmonic mean, anything mean as the initial guess. So this is for simplicity I've taken arithmetic mean. Then n is equals to number of iterations, then x naught is equal to x naught minus f of x naught minus derivative of x naught. Here, what I've taken. Okay. We are finding the function value at x naught and derivative value at x naught. So it is now mathematically ready. So it's a mathematical numerical function. So I can find the value directly. Then we are running this program for 15 times, whatever the initial conditions I have given. Then we got the root. Okay, is it fine? This program. I'll just show it from starting again. This is the user input function.
Excuse me, sir.
Ma'am.
Sir, in the initially the first statement from SymPy import symbols, comma, diff like that you are given. Can we give there also a star? Will everything be considered?
I can give here also from SymPy import star. Why I specially mentioned is I'm using only this for so make the difference. Instead of every time giving star, I'm giving like this. That's all. Only for our understanding. Like I'm using only 4. If I'm using very 10 or 12, instead of writing all the typing everything, I can put star. Here in the math,
Yes, I got it.
I don't know what type of input we can expect, so I put a star. So it can be any type of function, any math function you can give.
Okay. Okay, sir.
So here the differentiation. Here we can do the multiple types of differentiation also. like what do you say, partial differentiation, or we can go for differentiation for with respect to more than one variable also. And after this, I want to show one program where I can find the derivatives, multiple derivatives like partial derivatives and all those things. Any doubts in this program? So when we're going for the class, we should have a handful number of programs so that we can engage and we can do more number of features, what we can do with Python mathematically. So basically, a Python is a mathematical software. Nowadays, it become more popular because of the machine learning and data science. But basically, it's a mathematical software like MATLAB. Anybody executed any errors you're getting and discuss? So what I'll do is I'll copy everything in the Word document and I'll share it to the syllabus, all these programs. Okay. Fine. Any error? Able to execute?
Sir?
Any problem you're facing? Yes, ma'am.
In the afternoon session, can you please explain the same code with the graphical visualization, sir? We want that.
Okay, ma'am. Okay. I'll try to do
Yes,
that.
Newton Raphson
Actually,
with yes, sir.
I think for differential equations and for those things, we use a different visualization, but okay. Actually, I not tried before. Honestly telling, I not tried, but I'll write.
Yes, sir. Yes, sir. Because we have that only as per our syllabus, sir. If not for this program, any other code, graphical visualization, we want to see, sir.
Okay, okay, sure. Try.
Okay, thank you, sir. Yes, sir.
Okay. This is a see, this program is used for finding the partial derivatives. So in the SymPy, I imported star. Then we are defining the independent variables x and y. X comma y is equal to symbols of x comma y. The symbolic Python, so it will be in terms of symbols. So function here, this is a function is nothing but x square y cube minus 5 into y power 4 plus x into y power 3. That is function. So for power, we have to use double star, and for multiplication, we have to use single star. So these are basic things. Previous speaker might have covered these things. Okay, so that's why I'm not much stressing on these things. So first order partial derivative with respect to x. So DIFF, this is for derivative of function with respect to x means comma x. This is used to find the derivative of the function with respect to x. So this is a function I'm using, DIF. Then with respect to y, function comma y, DIF function comma y. So this is for differentiating the function with respect to y. Now second order derivative, second order partial derivative. So I want first d square f by dx squared. The function comma x. Let's start from the left onwards. So this is first derivative with respect to x. Second derivative is also with respect to x. So this is the partial derivative of second order. Then partial derivative with respect to y and again y. So second order partial derivative with respect to y. So DIF function comma y. So this will be the second order partial derivative with respect. Then first with respect to x, then with respect to y. So x comma y. This is d square f by dx dy. First x, then y. First derivative with respect to x and to the resultant, we are taking the derivative with respect to y. Then second order partial derivative with respect to y and x. So first one should be here. This is the first order derivative with respect to y and second order derivative with respect to x. So if I'm executing this program, this is for execution. So first you can see I have a x square y cube. So first what I will get 2x y cube. So this is a 2x y cube. 2x y cube. Then this is a completely function of y. So its derivative is 0. So we're not getting it. Then x into y cube. So derivative with respect to x. So it is y cube. So I got it. Fine.
Sir, I'm having one doubt here.
Yes. Yes,
Sir, you have taken this in the first line. You have taken the second derivative, that is x comma x.
sorry, sir. You are not audible.
So now I'm audible, sir.
Yeah.
Now I'm audible. Okay.
Yes.
So the second order partial derivative, you
Yes,
have
sir.
taken it diff of function comma x.
Yes, sir.
That is d square f by dx square.
Yeah, d square f by
Am I
dx
right,
square.
sir? Okay, sir.
Actually, it is
So
a dou
what if
square
I
f by
want
dou
to
x
get
square. Dou square f by dou
okay.
x square.
So, okay. So what if
Partial
I want
derivative,
to
ordinary
get
derivative can use only same thing, DIFF.
yes, okay, sir. So what if I want to get dou f by dou x whole square?
Dou f by dou x whole square. This function have to multiply once
Whole
again.
square. That is,
Yeah. We can have
so we have to multiply.
this multiplied with again this.
Okay.
That will give what you asked. D dou f by dou x whole square. That is. Okay,
Okay.
sir?
So if it n times, I have to multiply n times. So can't I do it like star or something like that? Star 2 or so probably star
no,
2
sir,
something like that.
No, we don't have like that.
So we have to do it. Okay, repeating itself. Okay. Okay,
Now,
sir.
with respect to y, x square is constant. X square is constant. Then y cube derivative 3y square. 3 into y square. Minus 20y cube. Then 3xy square. 3xy square. So now second order derivative of this with respect to x. So the second term is 0. no x term. This is 2y cube. Okay, sir. So you can observe that these two are same. Whenever the function is a continuous function in x and y, the derivative of dou square f by dou x dou y is same as dou square y into dou x. Okay. Same exponential function. This is a polynomial function. Same thing. We have done it on exponential function and trigonometric function. You can do it for anything. So that is important. That is the why if some simplifies with a less number of code with the direct functions, we can do a lot of things. So this is the x into e power x square minus sine square x plus 3 cos x plus 5. So when you give it, if you give only like x, it will not work. Like sine x, if you give, it will not work. It will show some error. It will show some error. So So this is about the partial derivative. So we can use this DIF function for derivative as well as for partial derivative. So any doubts? Any doubts? We have some time. Can I show some other programs? This program is for finding the Jacobian of two variables, two functions, two variables. So from simply import star x comma y symbols of x comma y. Here I'm defining u. U is x into 1 minus y. V is x into y. So I'm taking A as a matrix u comma v. So we have an inbuilt function called Jacobian. Jacobian with respect to x and y is the meaning. So here I'll get this matrix as dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So that matrix is displayed when you go for printing this Jacob. Jacobian is an inbuilt function in the SymPy. So we have a lot of functions. We just to know we have to just identify which function is in which package. Then we can do it all. Mathematical problems we can simplify very easily. We can find the values very easily. So here is a Jacobian matrix. So I got this derivative 1 minus y. It is nothing but dou u by dou x. Dou u by dou x means 1 minus y. This is dou u by dou y. So x minus xy, x minus xy. So we get minus x. Then dou v by dou x, second row, dou v by dou x, that is y. And this is dou v by dou y, that is x. Then this determinant. Here I'm going for determinant. Determinant of this Jacob A is determinant of this. So this determinant is nothing but x. 1 minus y into x minus of minus x into y. So we got this x. That is the Jacobian value. Then we can check the functional dependency also. The same program written. Once this Jacobian value is equal to 0, here I'm comparing. Here I'm comparing. When the Jacobian value is equal to 0, then the given functions are functionally dependent, else the functions are not functionally dependent. So here I've taken the function as x plus y by 1 minus xy, and this is the tan inverse x plus tan inverse y. Then we got this value 0. Then the given functions are functionally independent. This is the matrix. So ux, uy, vx, vy. And we go to the functionally independent. The same thing we are running for 3 variables. Here I've taken u is xy by z, y is v is yz by x, w zx by y. Then for 3 cross 3 matrix, so UVW, then Jacobian of x, y, z, the Jacobian of UVW with respect to x, y, z. So then we got the determinant. Here the determinant is 4, and this is the matrix whose determinant value is 4. Then same for 3 variables, functionally dependence. Same program, but 3 variables. But we cannot find the relation between them here. Relation between it cannot think manually, so we cannot find the relation existing between them. They are functionally independent. Actually, I have not tried it. I have to try this. That's all from my side, sir. Any doubts or any questions? Let me know. Sir?
Excuse me, sir.
I'm read out.
Excuse me, sir. Sir, the Jacobian method which you had explained us just now, can you please explain it to us without using that function, sir? Without using that function?
Which program?
That Jacobian we had explained, no, sir, just now.
Without that means you have to
Jacobian.
you have to use the differentiation, that one. We can use the partial derivative.
Okay, without.
Yeah, partial derivative.
Okay.
Then we have a inbuilt functions called determinant.
Okay.
Like we have debt.
Okay.
Debt
Okay,
we
sir.
have. So first you have to construct the matrix. Then we use the debt.
Yes.
That is the inbuilt function.
So the matrix, the matrix, if you are telling as an input, I should give the matrix, or the matrix is given by me in the program only.
No, madam. Here we are just giving the input as what do you say, the function UVW.
Yes.
He's taking the matrix using this Jacobian function. We'll create the matrix. This is the matrix.
Sir.
What we got.
Okay. Hmm.
This is the matrix. What we got. Then I'm taking the determinant. So we can get this matrix by using the partial derivative. So we have to construct this matrix, each row, each column like that. We can put it in a some for loop, and we can give an for loop, and we can append that.
Okay, sir.
We can append in each row wise. Then we can get the matrix form. Then we can take the determinant after that.
Okay. Okay, sir. Sir, also, there is one statement. Suppose I have import numpy as NP. That statement is there. That means NP is a variable or something which I created, or
No,
what
ma'am.
is that
No,
meaning,
ma'am.
sir?
Import numpy as NP means NP is an instance of numpy. If I
Instance,
take,
okay.
if I have some function in the numpy, like determinant, I can
Yes.
use like array. If I have an array, so I can use NP dot array. I just am giving like address.
Okay.
In the
Okay.
numpy, go to array, like that.
Yes.
So that is called an instance.
Yeah.
Instance means it will have all the features of numpy. I can say that import numpy as Mahesh. I can use Mahesh dot array, like that. NP will use this for
Sir, then,
like
yes, sir. Okay. So what difference is it making, sir? Now, suppose you have given from math import star. I can either like that, I can give here also from numpy
here,
import star.
suppose if I want to use a sign function, I can use math dot sign instead of giving the statement.
Okay.
Instead of giving the statement, I can give math dot sign x, like that. Here in the program, wherever I'm using the sign x or something like that. I think it's not in this program here, because it is an input function. We are giving user input. I cannot give it here. Here something like
Yes.
input function will be. Otherwise, can go here like here I cannot give here. Here I can give it as directly sign. Math dot sign also I can give it.
Okay, math dot sign. Okay.
Math dot sign instead of giving something like star, I can give directly math dot sign or math dot cos or math dot exp for exponential function.
Okay.
Just we are saying that this function is coming from which package. That array is a function.
Okay.
It is coming from numpy. So we can use instead of np dot array, we can use numpy dot array also. Doesn't make any difference.
Numpy dot array also we can
instance.
do. Okay.
Instance means still have all the features of numpy. So whatever,
Ah.
how can we use numpy? We can use np also like that.
Okay. Okay, sir.